Myself is Ravi Kumar. Actually, today we start the subject of control system. Now, in this control system, there are actually 5 chapters. Then first we'll start with the chapter 1, basics of control system. Okay. Before we start the subject of this control system, now just we will see a few important points regarding this particular subject. Actually, in the GATE examination, portion, now for this control system, the weightage is around 10 to 15 marks. Then the first point what I am saying is 10 to 15 marks in the GATE examination. Then you imagine, now in the GATE examination only 1 mark, which is very important because there is a negative marks and there is a large difference between ranks for a difference of 1 mark. Now in such a situation, 10 to 15 marks in the GATE examination, which is very good weightage. So the first advantage of this particular subject itself is weightage is very high in the GATE examination. Not only in the GATE examination, you take any competitive examination like a state government or central government examination also for EC and EE students, definitely the control system weightage is just 10 to 15 marks or 1 or 2 marks is a variation to the minimum to the maximum. So, and the second important one is this subject, which is very easy compared with any other core subject. Then you take any other core subject and you take this control system subject. Then you put a small effect, then definitely you can achieve a maximum marks in this particular control system. Then you compare with any other core subject. Definitely that much assurance I am giving. Once if you finish our course, you can easily understand. Once if you solve the question also, you have some confidence. Yes, this subject is easy and I can get a maximum marks in this particular subject. That particular awareness, that particular confidence, definitely you can get. Then that is the second point. And the third point is, and this point, which is the another advantage to you, that is we have some shortcut methods in this particular control system. Almost all the major topics and some topics will have some shortcut methods. Then that shortcut methods, which is very useful to you to get the questions in a very faster manner, and your time is also saving and you can easily get the answers, and that time you can utilize in the remaining question solvation. Now these are the main advantage of this particular control system. Before we start the subject, you keep these 3 particular points in your mind, which is very simple subject and we have some shortcut methods and weightage is more. So with these 3 important points, you can easily understand this subject. But any subject, then the basics is very important. That's why with the chapter 1, we start with the basics of the control system. Now I am writing here subject is very easy. No, when the subject is very easy, the subject is very easy once you are perfect at the basics. So once if you understand the basic portion, once if you understand the chapter 1, which is the basics of the control system, definitely I am giving the assurance that once if you have the basics, once if you understand the basics, definitely the subject which is very easy. So today we'll try to understand the concepts of basics of the control system, then we can easily understand the remaining portion of our control system. And then we'll start with the subject control system. Our subject is control system. Our subject is control system. Then see here, control system. So our subject is a control system. Now what is meant by a system? Then how we can define a system? So now first we start with what is meant by a system. Then, then whenever the system is a definition in our mind, so you take so many examples, like your engineering college is an example of a system, an industry is an example of a system, an organization is example of a system. What is meaning of a system? For example, take your engineering college is an example of a system. An engineering college consisting of students, faculty members, teaching, non-teaching, laboratory, libraries, all these are combined. All these are combined together. Am I right or not? Now, all these are combined together to produce some output for the given input. Well, this is the best example of a system. A definition of a system is nothing but a system is a group of all the physical components arranged in such a way that produces an output for the given input. Then that is the best definition of the system. Then we'll see here, this is system. What I am saying, what is the definition of system? System is a group of all the physical components arranged in such a way that it produces an output for the given input. It produces an output for the given input. But our subject is not a system. Our subject is a control system. Sir, then what is the difference between system and control system? I am already saying that control system, it is also a system. It is also a group of physical components. It is also a group of physical components arranged in such a way that. But what is control system? Now, for easy understanding, for better understanding, I am giving one small example. Let us assume this is your BTech first year. Let us say this is your BTech first year. Then your first year result is 40%. Your first year outcome is 40%. Then you put some preparation, then you are giving some inputs, and you can get some output of 40%. You are giving some preparation here, you put some inputs, you are applying some inputs, and your output is 40%. Then this is your first year results, let us assume. Then when the second year starts, then for example, when the second year starts, then you may think that no, this year I want to achieve 80%. Let us say, now you are thinking that no, this semester I want to get more marks, I want to achieve more results. Therefore, now in the second year starts, then your target is 80%. Your desired output is 80%. Now the question is, whatever the preparation you are doing here, if you put the same preparation, can you achieve 80%? Now in the first year, this is your preparation, this is the effect you are applying here, then you can get the 40% result. Then my question is, if you apply the same effect, if you put the same effect here, can you achieve 80%? No, it's not possible. So then now the question is, how to achieve 80% results? How to get 80% outcome? How to get this desired output? Then the answer is very simple. You are saying that no sir, in the first year I just apply only this much effect. Therefore, now in the second year, if you want to achieve 80%, if you want to achieve this desired output, only the normal preparation is not sufficient, sir. Only the normal input is not sufficient. In addition to the normal preparation, I want to put some extra effect. I want to do some extra hard work, sir. Sir, only the normal preparation is not sufficient. I want to do some extra hard work. I want to put some extra effort such that I am able to achieve 80%. You are saying? Yes. In the same manner I am saying, if you understand this simple logic, now the logic here is, now if you see here, I just give some effect, I just put some inputs and the result is 40%. But here, now I am applying some extra hard work, I want to do some extra hard work, I want to do some extra preparation here such that I want to achieve the desired output of 80%. The question here is, then if you understand these two logic, then this is logic 1 and this is logic 2, then this logic 1 is nothing but example of a system and this logic 2 is example of a control system, which means that then you can easily understand, sir, for understanding I am giving this 40%, 20%, 30%, but what is practically what happening? Practically what happening here, this is a system which you are giving some input and producing some output, but this is a control system, only input is not sufficient, the only input are not able to achieve 80%, the input, and you want to do some extra hard work, you want to do some extra preparation, you want to do some extra effort, only will give to achieve the desired output. Now, for a practical control system, sir, what is this extra effort? What is this extra hard work? That extra effort and that extra hard work is nothing but some controlling actions. Now you can easily understand. Now see here. Now finally I am just giving one conclusion. A system is a group of physical components arranged in such a way that produces an output for the given input. This is output which may be useful or may not be useful, but this is a control system. It is also a group of physical components arranged in such a way that produces a desired output. But if you want to produce a desired output, if you want to achieve a desired output, only the input is not sufficient, you want to do some extra effort, that extra effort is nothing but some controlling actions. This type of controlling actions are not available here, that's why it's just producing the output for the given input, but there is a controlling actions here that we are able to producing the desired output. Then if you see these two one, now the question is, which you prefer? You prefer a system or you prefer a control system? Without any second thought, we can easily say that, no sir, I want a control system, sir. I never want a system because it's producing output, but that control system is producing the desired output. So definitely we go for the control system. I want control system where it produces the desired output, where it will apply the controlling actions. Now the question is, now what is the difference between system and control system? What is the difference between a system and control system? Then you can easily answer, now there is no controlling actions here, now there is a controlling actions here. Now there is a controlling actions here. Based on this controlling actions, now this is able to produce the desired output. Therefore, now you are saying that the difference between a system and a control system is controlling actions. Therefore, based on this controlling actions, now this control system is classified into two types. One is open loop control system, another one is closed loop control system. Now see here, based on controlling action, this control system is divided into two types. One is open loop control system and the second one is closed loop control system. Sir, then what is open loop control system? What is closed loop control system? So the control system appears like a open, therefore this is open loop control system. The control system appears like a closed, therefore this is closed loop control system. That is a wrong statement. No, that statement is not correct. So it is appears like a open, it is open circuit. It is appears like a closed, it is closed circuit. Closed loop control system is the wrong definition, because we are not based on open circuit, we are not based on closed circuit. This is open loop and this is closed loop. Now if you observe here, based on controlling actions, this control system is divided into two types. One is open loop control system, another one is closed loop control system. Therefore, you define a open loop control system, you define a closed loop control system only based on this controlling actions. Therefore, before we see the definition of these two control systems, now in these two control systems, first of all, we want to achieve desired output. First of all, we want to achieve a desired output. Now see here, in these two control systems, we want to achieve the desired output. Sir, why we are achieving the desired output? Because this is open loop control system. This is closed loop control system. A control system where it will produce the desired output. And if you want to achieve the desired output, we need to apply some controlling actions. We need to apply some controlling actions. Therefore, in these two control systems, we are applying controlling actions. Once we are applying controlling actions, now we are expecting the desired output. Therefore, these two are the examples of the control systems. Therefore, we are applying some controlling actions. Once there is a controlling action, then we are able to achieve the desired output. Therefore, now the question is, sir, which control system is preferable? A open loop control system or a closed loop control system? Both the control systems are producing the desired output. Both the control systems are applying the controlling action. Sir, which control system is preferable? A open loop control system or a closed loop control system? Which control system is good? Open loop control system or closed loop control system? Our subject is control system, and which control system we are going to be discussed? A open loop control system or a closed loop control system? That we can discuss, that we can decide it later. Before that, we want to see what is the definition of open loop control system, how it will define, how it will work, what is the definition of closed loop control system, how it will define, how it will work. Once if you have these two differences, then we can understand now which one is preferable, which one is not preferred, which one is good, which one is not good, that we will decide. So before we start the definition of open loop control system and closed loop control system and analysis of open loop and closed loop control systems, then we just take difference of a system and control system and what are the different types of control systems. Okay, just take this one, and after that we move further. Now what is open loop control system and how it will define and how it will be useful practically or not, also we will see. Okay, then now first we will define a open loop control system, and we will see the blocks of the open loop control system and definition of open loop control system we will see. Whether it is a open loop control system or a closed loop control system, now there is an input. A reference input. But this is a open loop control system. A control system is producing some controlling actions. Therefore, this is a controller. This controller will produce some controlling actions. Now see here, this is the input and this is the controller. This controller will producing some controlling actions. Now this input is fully under the controlling actions produced by the controller. Therefore, this is nothing but, we can say, controlled input. Now this controlled input is further processed. This controlled input is further processed, and this we can say as processed output, or finally this is desired output. Of course, we are applying some controlling actions, and we may call this is some controlled output. Now if you see here, now if you observe here, input, controller will apply some controlling actions. Now this input is fully under the controlling actions produced by the controller, therefore this is controlled input, and it is further processed, therefore this is processed output, or this is called as desired output, or this is called as controlled output. Therefore this is a block diagram of open loop control system. But this is the block diagram of control system. But if anybody will look this block diagram without the second thought, all of you are saying that now this is example of a system or a control system. No doubt, this is control system, because controller is available and controlling actions are also available. Therefore, this is a control system. But my question is, which type of control system it is? Which type of control system? This is a open loop control system, or this is a closed loop control system? Now this comes under open loop control system or closed loop control system. So this is a open loop control system or this is a closed loop control system. Then you tell me, this comes under open loop control system or this comes under closed loop control system? You are thinking that, sir, this is appears like a open, therefore this is open loop control system. This is not a closed one, sir, therefore it is not a closed loop control system. That is a wrong analysis. That's what I am saying. Don't judge that based on the appearance of this particular system. Sir, this is appears as a open, so open loop control system. This is appears like a closed, therefore this is closed loop control system, is a wrong definition. Now the question is, whether open loop control system or a closed loop control system, you can decide it only by looking this controlling action. See this controlling action. Only based on this controlling action, we can decide it a open loop control system or a closed loop control system. Sir, then for understanding the definition of open loop control system or a closed loop control system, then I will take one simple example. Then we'll take one simple example and we will define a open loop control system, and this is a block diagram of open loop control system. Now this is a block diagram of the open loop control system. Then I will take one small example such that you can easily understand the definition of open loop control system. Now one simple example in our day-to-day life observation, you may observe a number of times this particular example. Now see, this is, let us say this is case 1, and case 1, this is one nearby junction. Assume some junction here, the combination of more than 2 roads. This is a junction. Now the situation at this junction is, there is no traffic signal. Right? Now see here, this is a junction. At this junction, combination of more than 2 roads. Now the situation here is, there is no traffic signal. Now in this situation, same junction, the same junction, then what I am doing is, then I just put a traffic signal. Now you tell me, is there any differences between case 1 and case 2? You observed any differences between case 1 and case 2? Definitely you are saying that, sir, here there is no traffic signal, here there is a traffic signal. I am already writing here there is no traffic signal, here traffic signal. What is the difference? What is the meaning of that? Then you can easily say that, sir, there is no traffic controlled here, sir. There is no controlling of traffic, but you are saying here traffic is controlled. So why we are saying that here traffic is controlled? Then which means that here some traffic signal is installed. So you are saying that, sir, here there is a traffic signal, which means that a traffic is controlled. Traffic is controlled. Now my question is, you are saying there is a traffic signal here. There is a traffic signal here, which means the traffic is controlled, but no traffic signal, no control the traffic. Traffic signal, traffic is controlled. Traffic is controlled means this is the controlled output. When you can get the controlled output? When you can get controlled output? You can get the controlled output when there is a controlling actions are present. Traffic is controlled means controlling actions are applied. Traffic is controlled means controlling actions are applied. Then you tell me, now you see here, traffic is controlled, controlling actions are applied. Then come to this particular block diagram. If you come to this particular block diagram, now see here. Now what is the controlling actions? Traffic is controlled means what is the controlling actions? Now see here, the controlling actions is this red light will be indicated for 60 seconds. This green light will be indicated for 60 seconds. Now these are the controlling actions. When the red light will be indicated for 60 seconds, when the green light will be indicated for 60 seconds. So these are the controlling actions which we are applied here, and the traffic is controlled. What is the output? Now this is controlled output. Now this is controlling actions and this is controlled output. Then what is the meaning of this? When the red light will be indicated for 60 seconds, yes, the traffic is stop for 60 seconds. When the green light will be indicated for 60 seconds, yes, the traffic is move for 60 seconds. Because this is the controlling action and this is the desired output or controlled output, because when I put the traffic signal, my traffic is to be controlled. Yes, therefore this is the controlled output. Now the question here is, if you just observe, these are the controlling actions and this is the controlled output. These are the controlling actions and this is the controlled output. The question here is, now the situation, only one or two persons, only one or two persons at the junction, only one or two persons. You tell me only one, you and your friend are there at the junctions, then how much time the red light will be indicated? 60 seconds. Now only one or two persons at the junction, the red light will be indicated for 60 seconds and obviously the green light will be indicated for 60 seconds. More traffic, 300 members. Now there are 300 members, then you tell me how much time the red light will be indicated? 60 seconds. How much time the green light will be indicated? 60 seconds. When there is no traffic, when there is full of traffic, when there is no traffic, when there is full traffic, when there is no traffic, when there is full traffic, then the red light will be indicated for 60 seconds. The red light will be indicated for 60 seconds and the green light will be indicated for 60 seconds. When there is no traffic, when there is no traffic, when there is full of traffic, then the red light will be indicated for 60 seconds and green light will be indicated for 60 seconds. Here the question is, only you and your friend, only two persons are there. If you and your friend, only two persons are there, then why unnecessarily waiting of 60 times, 60 seconds? Only you and your friend are there, then why unnecessarily waiting of 60 seconds? If it is changed from 60 seconds to 5 seconds or 10 seconds, it is good. But that you are expected in our traffic signal. Then you daily you are traveling on the road, then you may came across so many number of traffic signals, then you observe what type of situation you are facing. Then only you and your friend are available at the junction, then obviously the time based circuit will be waiting for 60 seconds and the red light will be indicated for also 60 seconds. It remains same, constant. It is also same. Once it is fixed, then this is fixed for 60 seconds, this is also fixed for 60 seconds. Then what is the meaning of that? What is your observation from this particular example? Now if you observe here, this is controlling action and this is controlled output. This is the controlling action, this is the output. What is the relation between these two? Then if you observe here, now the controlling actions and controlled output, the controlling actions and this controlled output is completely independent each other. Then see here, is it right or not? Why independent I am saying? Whether one or two members are full traffic, there is no traffic, then the red light will be indicated for 60 seconds and the green light will be indicated for 60 seconds. No traffic, full traffic, then the red light will be indicated 60 seconds and the green light will be indicated for 60 seconds, which means that the controlling actions and output are completely independent each other. The controlling actions and output are completely independent each other. So what is the definition of control system? What is the definition of open loop control system? A open loop control system is a system in which the controlling actions or output are completely independent each other. In which control system the controlling actions and output are completely independent each other, such control systems are comes under the category of open loop control system. Therefore, this is a open loop control system. Open loop control system. A open loop control system is a control system in which the controlling actions and output are completely independent each other. That is example of open loop control system. I am not defining this open loop control system definition based on open circuit, based on closed circuit, based on current zero, based on voltage zero. Wrong. It is not open circuit, short circuit, voltage zero, current zero. No, this is based on controlling actions. The controlling actions and output are completely independent each other. Such control systems are said to be open loop control system. Then this is a open loop control system block diagram, and this is a simple example I am taking. And what is a open loop control system definition, and this is the block diagram of open loop control system. Just take this one. This is open loop control system block diagram and the definition of open loop control system, and take this block diagram, which is very useful for further analysis of our subject. I think you can easily understand the definition of open loop control system. Then again I am saying definition. What is the definition of open loop control system? A open loop control system. A control system is said to be open loop in which the controlling actions and controlled output are completely independent each other. A control system is said to be open loop in which the controlling actions and output are completely independent each other. In which control system the controlling actions and output are completely independent each other, that control systems comes under the category of open loop control system. Then here itself you can easily understand the definition of closed loop control system, in which control system the controlling actions and output are completely dependent each other, then such control systems are said to be closed loop control system. Don't worry, we will see the closed loop control system separately with the example. There you can easily understand, but here itself you can have a major difference between open loop and closed loop, in which control system the controlling actions and output are completely independent comes under open loop control system. In which control system the controlling actions output are completely dependent, then such control systems are said to be closed loop control system. Anyway, we will discuss closed loop control system separately, not a problem. Here we concentrated on the open loop control system. See here, this is the open loop control system definition. Now controlling actions and this is controlled output are completely independent each other. Now one more thing also I am saying. Then here the controlling action, in the previous example we are saying, in the traffic signal example, the controlling action is nothing but the red light and green light which we are applied here. Manually we are applied, and this is 60 seconds and 60 seconds, and some areas you may observe 40 seconds or 40 seconds or 30 seconds or 30 seconds like that. Then one simple example I am saying, see here, if you take a fan, now if you take a fan here, that is a fan, then see here, this is a fan. Then if you take a fan here, now in the fan you just remove the blades. Now this is the fan, you just remove the blades of this particular fan. Now you switch on. Then you tell me, this is an example of a control system or a system or an open loop control system or a closed loop control system. Tell me. A fan without any blades is a system or a control system? Some of you are saying system, some of you are saying control system. But you just think a minute, this is a fan, purpose of producing, a purpose of generating, a purpose of giving a constant airflow to us. But if you remove the blades of the fan, is there any constant airflow you are getting? Is there any output? If there is no output, then can we say the system? Can we say any control system? No, which means that a fan without blades is not a system. Means, see the first case, fan without blades, not at all a system. Because it doesn't produce any output. That is useful or not, that is a second case. But it not producing any output, it is not a system. It is not at all a system. Now case 2, fan with blades. When a fan with blades, it is rotating and it producing a constant airflow for us, means it is output is a system because it produces some output. Now the question here, fan without blades, fan with blades. Now the third one, what I am doing here is A fan with blades, a fan with blades, it is rotating and producing a constant airflow. Now what I am doing is, now that airflow is now I am controlled by using some regulator. Fan with blades and with regulator. Now you tell me, a fan with blades and with regulator. Regulator means what? You put in the regulator mode 1, 2, 3, 4 means you are applying some controlling action. So the output is controlled or not? This is controlled output because you are applying some controlling actions. So you are giving some controller, you are applying some controlling action and output is controlled. Now you tell me, that is example of a system or a control system? Then obviously you are applying some controlling action. Therefore, this is without any second thought is a control system. Very good. Is a control system. Then you can easily understand what is meant by a system, what is meant by a control system, what is not a system. Understand or not? Yes. The same thing here is also. Then if you take this example also, see here. Now this is the open loop control system. Now here the red light or green light, or we are applying the controlling actions here. Therefore, now in a open loop control system, now this controlling action produced by the controller is a manually operated one. This is manually operated one. Now see here. Now in a open loop control system, the controlling actions and output are completely independent each other. Now in open loop control system, the controlling actions produced by the controller is a manually operated one. Therefore, now see here. The controlling actions produced by the controller is manually operated one. Therefore, open loop control systems are also called as manually operated control system. Manually operated control system. Therefore, now why this is manually operated control system? This is manually operated control system because here the controlling actions are manually operated. Then we adjusted in the time-based circuit 60 seconds, 60 seconds, 40 seconds, 40 seconds. Am I not? Therefore, this is a manually operated one. Then you put knob as regulator 1, 2, regulator position 2, regulator position 3, regulator position 3. Therefore, this controlling actions produced by the controller is a manually operated one. Therefore, open loop control systems are also called as manually operated control systems. Now here is also I am giving one simple example. Let us take example of air conditioner. In the air conditioner, what you are doing in the air conditioner? You just set the temperature. You just set the temperature as 20 degrees centigrade. That's it. It is closed. Once if you set the temperature as 20 degrees centigrade, then automatically the air conditioner after some times it will make the room temperature as 20 degrees centigrade. Right? Not. Then you take automatic iron box, fully automatic iron box. In the iron box, you just set the temperature as 20 degrees, as some 30 degrees or whatever the temperature. You just set the temperature on the iron box, and after some times, once the temperature is reached, the iron box is automatically gets off. Or fully automatic washing machine. Then you just put the cloths and you just you just switch on the washing machine. Then after washing the cloths, then it will automatically gets off. These are fully automatic. What is the meaning of fully automatic? The fully automatic means that it consisting of some sensors. which consisting of some sensors. Sir, now here this is not automatic, this is manually operated one. This is manually operated one. That's why the open loop control systems are also called as manually operated control systems. Therefore, so sir, can I say like that? A control system which consisting of sensors comes under the category of closed loop control system. Then I will take another important point here. This is one important point. And the second important point here is a control system which does not consisting of sensors comes under open loop control system. Is it right or not? You understand? A control system is fully automatic, but this is not automatic. This is manually operated control systems, because here the controlling actions are manually operated one. Therefore this is manually operated control systems, and a control system which does not consisting of a sensor comes under open loop control system. In a reverse definition is a control system which consisting of a sensor comes under closed loop control system. Now there the controlling actions are fully automatic, therefore that is automatic control systems. Which control systems are automatic? Which control systems are having sensors? That is closed loop control system. Okay, but here we are talking about a open loop control systems where it is manually operated one, where there is no sensors. Okay, so anyway, we will see the definition of closed loop control system separately, and we will see the examples of closed loop control system separately. But this is a definition of open loop control system, block diagram of open loop control system, and these three important points. So the first important point here is the controlling actions. Once again I am recollecting. Now this is the first point. The controlling actions and output are completely independent each other. Such control systems are open loop control systems. And the second important point, open loop control systems are also called as manually operated control systems, because here the controlling actions are manually operated one. And third important point, a control system which does not consisting of a sensor comes under open loop control system. With these three points, you can easily have a definition of open loop control system and a closed loop control system. Now this is the story about a open loop control system. You just take the definitions and these important points and this block diagram of a open loop control system. This is comes under a open loop control system. This is totally the open loop control system block diagram. You just take a copy of this. Then after that we will see what is closed loop control system and what is the block diagram of closed loop control system and how it will work, what is the definitions, and everything also we will see. And you take this example also, you can have what is meant by system, what is not a system, what is control system. You can easily understand with this particular example also. You just take a copy of all these things. Okay, then you understand the basics of the control system. The first portion what we are discussed is system, control system. In the control system there are two types of control systems. One is open loop control system and one is closed loop control system. But based on controlling actions, it is defined as open loop control system and closed loop control system. So based on controlling actions only, then we categorized open loop control system and closed loop control system. So controlling actions and output are completely independent. Now therefore this is a open loop control system, and where controlling actions are manually operated, therefore open loop control systems are also called as manually operated control systems. And in a easy understanding, in a easy definition, in which control system which does not consisting of a sensor comes under open loop control system. Then if you understand these three definitions, exactly those three definitions are in a reverse way, then that is comes under closed loop control system, where a controlling actions or output are completely dependent, and where in the closed loop control systems are automatic. Therefore this is automatic control systems, and a control system which consisting of sensor comes under closed loop control system. Okay, not a problem. We can take a separate a closed loop control system black diagram and examples, definitions and everything we will see separately in the next session. Okay.